Today's May 31st, 2011. Okay, technically we're on textbook page 424, Blue Notebook page 514, lesson 8.4. But lesson 8.4 is essentially just problem solving. There are really no new theories we have to learn. We can take up some of those questions. But what I'm going to do first is I'm actually going to recap right angle triangles, when to use what looks like what, and so on and so forth. And then we're going to go over non-right angle triangles, when to use sine law, when to use cosine law. Okay? So, actually, you know what I'll do? Okay, so remember, right now we're starting with right angle triangles. So right angle triangles. So this is a right angle triangle. Let's, for instance, say we have, this is 4 meters long. This is 5 meters long. They've only given us information. Does anyone know what formula I can use to solve this? Pythagorean, okay? So I can use a squared plus b squared equals c squared. And remember, I'm looking for the hypotenuse here. Hypotenuse is referring to c squared, so essentially, I can call either of these a and b. It doesn't matter. Call that a and this b. This formula says 5 squared plus 4 squared equals x squared. 25 plus 16 equals x squared. 41 equals x squared. And x is whatever the square root of 41 is. Type that in our calculator. Oh, I can't find the... Just want to make sure you guys can see how to do it. 6.4. So, our x is 6.4. Now, let's say with that same style triangle, we'll draw another triangle down here. Well, that's pretty good. Let's say we have hypotenuse is 6.4. This is 5. And we're looking for this side of the triangle. What formula can I use? Pythagorean, again. Okay? The only difference is this has to be our c. So 6.4 is our c squared. Again, let's just call 5a and xb. So our a is 5 squared, and our b is our x squared. Okay? 5 squared is 25 plus x squared equals 6.4 squared, 40.96. Now, I need to isolate x, so I'm going to bring 25 to the other side. This becomes x squared equals 40.96 minus 25. Subtract that on our calculator. X squared equals 15.96. And if I square root that number, we get 3.99999, which is going to round to 4. Now, if you guys notice, it didn't give us exactly 4. Even though our measurement above here, we knew that b was going to be 4. That's because I had rounded the c. The square root of 41 is actually 4, or 6.4, and on and on and on. So because I rounded, you guys notice it's a little different. So this is approximately 4 meters long. Okay, and finally, we're going to go into a lot of depth here, guys. We're going to do the exact same question again, solving for the other side. Pretty redundant, but important that we know. Let's say they've given us this. We're looking at for that side. We're still using Pythagorean. Again, that has to be our C. This time we're going to be looking for A. And this is our B. X squared plus 4 squared. This is 40 0.96, 16, x squared. When we bring 16 to the other side, we have x squared is equal to 40.96, subtract 16. We get 24.96. And we square root that number to find our answer. 4.9, again, which rounds to approximately 5. So once again, we saw for every side of this triangle, those are the 3 exact instances that you could use Pythagoras' theorem. Okay, in this question, again, a right angle triangle. We're going to go over tangents. Okay? So tangent is tan theta, opposite over adjacent. So we know this is right angle. If this is the angle we're working with, this is our opposite side. This is our adjacent side. So any combination where we have those, we're going to be able to solve using tangent. So let's quickly take a look at this. Let's say we have a triangle. This is, again, 5. This is 4. We're looking for this angle here. We have, according to this angle, remember we always refer to whatever angle we're working with. We have the opposite and the adjacent, so we quickly set this up. Tangent theta, we're trying to solve for theta, is the opposite, which is 4 over 5. Tangent theta is equal to 0.8. We're going to bring tangent to the other side. Becomes the inverse, 0.8. Type this in our calculator. Let's make sure 4 divided by 5. Yeah, I thought so. Second function, tan. Answer from before. And our angle is 38 point, let's say, 65. We're going to say that's approximately 39 degrees. Okay? Same triangle. We're going to go methodically through all this. This is 39 degrees. This is 5. We're looking for this angle. Again, because we're dealing with this angle here. Sorry, we're not looking for an angle. We're trying to find the opposite side of that angle, and we have the measurement of the adjacent. Set up another tangent formula. Tangent 39 degrees is equal to the opposite, which is our x, over our adjacent, which is 5. I bring the 5 over to the other side. I get 5 times tangent 39 equals x. I can do that all in one step on my calculator. Tangent 39, enter, times 5, 4.4. So it is roughly, if we were to round this, it's approximately 4 meters. Exactly what we had before. Correct? And one more time, because there's always that many options with tangent. 39 degrees is this angle, we'll say. This time we're trying to find the adjacent, and we have the opposite. We're using our tangent. 39 is equal to opposite, which is 4, over adjacent, which is x. This one's where we get a little more difficult. Fastest way to do this is just actually switch the x and the 39, or tangent 39. Think of it like that. All we did was switch tangent 39 and x. We get the exact same thing. So this time, I'm going to go 4 divided by, and I'm going to put in brackets so my calculator knows to do tangent 39 first. 4.93 Started around that, I'm looking at approximately 5 meters. Exactly, again, what we had above. That's everything to do with tangent. Okay, sine law. Or sine ratio, sorry. It's right angle triangle. We're going to use the same type triangle. Let's say we have 39 degrees again. And this is 5. And we're looking for the hypotenuse. We set up our sine, 39 degrees, is equal to opposite. Oh, sorry, we need the opposite in this one. No, this is 4. Over hypotenuse, which is x. Okay? Same idea as we've done before. We flip the x into 39. So x equals 4 divided by sine 39. And we do that in one step. 4 divided by bracket sine 39 and bracket equals 6.3. So our hypotenuse of our triangle is 6.35, which is approximately 6.4. We found that earlier on Pythagorean when we used Pythagorean's theorem. Same idea. Let's say we have 6.4, 39 degrees, and we're solving for the opposite side. Sine 39 equals opposite over hypotenuse. I just got to bring 6.4 to the other side. Equals x. Sine 39 equals times 6.4. X opposite side is 4.02. So approximately 4. Okay, and finally, let's say I'm looking for theta. We know that this is 6.4 and this is 4. Sine theta is opposite, which is 4 over hypotenuse. 4 divided by 6.4 is 0.625. Sine theta. Bring sine to the other side, it becomes inverted. Second function, sine to the answer from before. Discover that theta is 38.68, approximately 39 degrees. Same we found on all the previous pages. And we'll do cosine ratio. Okay, cosine ratio. Right angle. Make sure you're dealing with right angle triangles. Okay, we have 39 degrees. We have the adjacent side. We're looking for a hypotenuse. Cosine of 39 degrees is equal to adjacent over hypotenuse. We can just flip the x and the cos 39. X equals 5 divided by bracket cos 39, 2 brackets, 6.4, which is exactly what our hypotenuse was in the other one. Same type of question. 39 degrees, this is 6.4. We're looking for the adjacent. Cosine of 39 is equal to adjacent over hypotenuse. I just bring 6.4 over to this side. Cos 39 times 6.4 gives us x is 4.97, which is approximately 5. Exactly what we knew from before. And last one. We're looking for the angle this time. Not sine, sorry, we're on cos. Cos theta is equal to adjacent, which is 5, over hypotenuse. Cos theta is equal to 5 divided by 6.4. Get a ridiculous number, 0.78125. When I bring cos to the other side, it's inverted. So second function, cos, to the answer from before. And we get an angle of 38.6. Theta is approximately 39 degrees. And depression. Okay, finally, angle of elevation. You are this person here, and you need to find the angle of elevation. That means from your foot, or wherever we're measuring from, we draw a straight line. Oops, which that is not. We draw a straight line, and from that point upwards, creates an angle of elevation. That's what we're looking for. Now, angle of depression. This is very important. Many of you guys have missed this. If I ask for the angle of depression, again, a straight line from that point, heading downwards. This is an angle of depression. I can handwrite on this. There we go. Elevation and depression.